All right. Hey, everybody. Hope you're doing well. So what I'm going to do today, this will be a math video. So if you're in my Sec 1 math class, before we stopped going to school, we were talking about geometry a little bit. We didn't get too far with it. So what I thought I'd do with this video today is go over a couple of ideas that you're really going to need to know for geometry and angles, which is what we've been talking about in Sec 2, Sec 3, Sec 4. You get the picture. So I'll show you this. This is entirely optional. You do not have to do this for marks. There's nothing to hand in. You don't need to write anything down. This is just if you are bored and looking to have more math in your life, which I'm sure is the case for all of you. So I'll go over that. Just before we get started, though, a couple of things that you need to know. First of all, as I said, this is optional. This is what I'm going to call enrichment. So if you are doing well in math, if you have had a good term 1 and good term 2, I would recommend that you watch this if you have the time. Probably do. But if you are not, if you have struggled in math, if you're failing, if you have a failing cumulative grade, you've already received an email from me, or your parents have received an email from me, and I would recommend that you do not focus on this, because this is not going to count for anything. This is, if you are failing, I want you to concentrate on term 1 and term 2 material. So you can go into Math Help Services, you can check back on your stuff to get a little bit more information on that. All right, I've already assigned you a few things if you are failing on Math Help Services. So check that out. If you're having trouble logging into Math Help Services, you need to send me an email. Okay, so with that, let's get started on this video stuff. I'm going to give you a couple of vocabulary words here that are going to be useful to know. So the first one is going to be something that I call complementary angles. So I know my head may be in the way of this. I cannot move it. I'm sorry. But simple definition here. When I say that two angles are complementary, it just means that if I add them up, they total 90 degrees. So here is a right angle that is 90 degrees. You can tell by the little square here. So I am going to say that angle ABC is 90 degrees. It's a right angle as we go from A to B to C. But now let's add another line in here. I've just made two angles. I've got ABD and I've got DBC. So if I add those two together, I'm going to say that they total 90 degrees. Therefore, angle ABD and angle DBC are going to be what I call complementary. That's it. Okay. Now, if you don't like having all those letters all over the place, I like this. Less letters, a little bit easier to see. This small angle here, I'm going to just call M. I don't know what it is. I'm not even going to bother to measure it. I'm not going to bother with a protractor. N, I don't know what that is either. But if I combine M and N, I can tell that I'm going to get 90 degrees. So M and N are complementary angles. Okay. Here's another definition. Again, I'm sorry if I'm in the way, but similar idea. Two angles that add up or that to total 180 degrees or form a straight line are going to be called supplementary angles. So let's draw ourselves a line. We've got AB. I'm going to put in another line here, CD. All right, so I've just made a couple of angles. What I can say is that as I go from A to D to C and C to D to B, those two angles are going to total 180. So therefore, I can say angles ADC and CDB are supplementary. So complementary means they add up to 90. Supplementary means they add up to 180. Okay? Again, you don't have to use all these letters. I like this better. X and Y. I don't know what X is. I don't know what Y is, but I do know that they add up to 180. So X and Y are supplementary angles. Okay? Now, if I'm going too fast, by the way, just pause the video, rewind if you want to see something again. But here's a couple of examples that you could have faced in an assignment or on a test or at some point. And the nice thing is I've given you an angle here and you can automatically figure out the other one. So I've got a whole bunch of right angles here. If I look at this one, I've got a right angle and I'm telling you that this part of it is 51 degrees. So what must be the value of angle W? Well, it's going to be 51 plus whatever gets me to 90. That'll be the value of W. So to figure that out, you can use a calculator if you want. but you're going to be subtracting 51 from 90. You're going to get that W must be 39 degrees. Okay, so you can pause it and try the other ones if you want. But the nice thing is, if I give you one of them, you can quickly work out the other. In fact, even quicker than you think, because you don't need to show me this work, to be honest. You can look at this and just say, X must be 53, because 53 plus 37 is going to get me to 90. All right, now the little red square is on the outside here, but this too will be 90 degrees. Okay, that's important to realize. Same thing here. This is also a right angle. The little red square might be here, but it means that this must also be a right angle. Okay, so 31 plus what gets me to 90? Well, it's got to be 59. And here, 54 plus what gets me to 90? It's going to be 36 degrees. So these are all complementary examples. All right, let's look at some supplementary examples now. So here, I've got a straight line and an angle being made here, two angles, 116 and the other one I'm calling A. I know there's some weird triangle stuff going on here, but you don't need to worry about that. That does not affect what we were talking about. We've got a straight line, 116, and whatever that is. Well, if you remember, a straight line is 180. 116 plus something must get me to 180. So you can work out that that value of A must be 64 degrees. So go ahead and find the values of B, C, and D. Take a minute to do it. Pause if you want. All right. But for B, we're asking, what do we have to add to 34 to get to 180? Well, it must be 146. For C, what do we have to add to 128 to get to 180? Well, it must be 52 degrees. And for D, what do we have to add to 125 to get to 180? Well, it's got to be 55 degrees. So remember, these have to total 180 degrees for them to be supplementary. Okay, so two words we've learned so far: complementary, supplementary. Let's go with another one now. Okay, so I'm going to give you two lines here that intersect. Okay, remember, intersect just means they cross one another. And the nice thing here is it does not matter at what angle they cross each other at. Okay, we're going to make four angles whenever we've got an intersection. I'm just going to call them A, B, C, and D. And again, I'm sorry if I'm in the way here, but when intersecting lines create four angles, the angles that are across from one another are always going to be equal. So I don't even know what angle A is. I'm not bothering with the protractor. The protractor days are pretty much done right now. But it's going to be the same as angle C, all right, because it's across the intersection, all right? So I can say this, but we're going to, oh, and I'm going to put that little notch here, if you remember. That tells me that these two angles are the same, all right, because they're across from one another. But there's a specific math term for when angles are across from each other in an intersection like this, and I'd like you to know it. It's a good thing. It's going to be, we're going to say that angles A and C are vertically opposite, okay? So when an angle is across from another one and it's the same in an intersection like this one, we're going to say that they're vertically opposite, all right? So what about D and B? Are they the same? Yeah, they are, all right, because they're across from one another. And we are also going to call them vertically opposite. So every time I show this, students say, sir, shouldn't we call them horizontally opposite? And I go, well, yeah, but that's just not how it works. There's only one term to remember here. Even if they're left and right, like they are here, they're going to be called vertically opposite, okay? So I know I don't think of vertical really when I look at angles B and D here, but at least it's just one term to remember, okay? So I'll put two little notches there to show that angles B and D are the same. They are also vertically opposite because they're across from each other. So here's some examples. And the great thing is with any of these intersections is the moment I give you one value, you can figure out all the rest. So if I tell you that that particular angle is 40 degrees, well, then you can figure out, because this is a straight line, what must I put over here to total 180? You're going to work out that this has to be 140. Now, let's do this angle over here. Well, it's opposite or vertically across or vertically opposite the 40-degree angle, so it must also be 40. And then this angle, it's vertically opposite the 140, so it also has to be 140. Okay, here's another intersection. The moment I give you this one, 97, you can figure out all the rest. So go ahead and try it. If you do this, this one, well, it's got to be 97 plus something gets me to 180, because this is a straight line. 83. And now, because things are vertically opposite, we know that this must also be 97. This must also be 83. Okay, one more example here. This is a pretty flat intersection, and this is a pretty big angle, 165.7 degrees. Don't be afraid of the decimal. It's not going to change what we do here. You're still going to figure out, what do I have to add to this to get the straight line, 180 degrees? Well, it's going to be 14.3 degrees. That means that, let's go vertically opposite again. This one is opposite, so it's also 165.7. And this one, also 14.3. So this is what we mean by vertically opposite. It just means across from one another. And it's always true no matter what kind of intersection you have, as long as it's made by two straight lines. Okay, so one more situation I want to show you in this video. And to show you, I'm going to start with two lines. I'm going to call this one AB, and this one CD. And I am going to tell you, and you need to know this to be able to answer this, that both these lines, AB and CD, are parallel. That means that if we continued them, they would never, ever meet each other. Okay? Now I'm going to draw another line through it called EF. Now, did I make perpendicular angles here? Well, no. If you look at it, you can see these are not, I've not made any right angles. No. So I'm going to say that EF is something called transversal. It just means I've had a line that cuts right through it, but not at 90 degrees. Okay? And I've made a couple points of intersection, G and H. All right? So let's get that out of the way. And here's something interesting. I'm going to give you, because if you look, we've got 8 different angles here. I'm only going to give you one of them. I'm going to say this one, angle EGB. So from point E to G to B is 38 degrees. Believe it or not, I've just given you enough information to find every other angle. Okay, let's try this. Let's work through how we know to do this. Well, 38 plus this is going to get me a straight line. So what must I add to 38 to get to 180? Well, it's going to be 142. So angle AG E is going to be 142 degrees. All right, now we know about vertically opposite angles. This one is across from 38, so it's also 38. This angle is vertically opposite the 142, so it's going to be 142. Okay, so this is what we've already done. But the interesting thing is, and this is true all the time when you've got parallel lines, is that whatever's going on up here is going to be the exact same story down here. So I can actually fill in the rest of it. This is also going to be 38 degrees, which means this is 142, which means this is 38, which means this is 142. And again, this is always true when you've got parallel lines and this transversal cutting through them. Once you know one angle, you can actually figure out the other 7. Because if you look, they're all the same. They're all either 38 or 142. Okay? So here's another way to look at this, and I'm going to just go over a bit of vocabulary that you're going to see when you encounter this. So for this, I've just shortened this. I'm only going to call them angles A, B, C, D, E, F, G, and H. And what I want you to notice is that angle A is the same as C. It's also the same as E. It's also the same as G. Okay, we can tell by those little notches. So let's actually talk about angle A for a moment. All right, I just told you it's the same as angle C. And why is that? What's the specific math term that I gave you in this video that you would say to tell me that they're the same? Well, if you've been listening, you're going to know that A and C are vertically opposite angles. Okay? That's not the only story going on here. We also said A and E are the same angle, but these are not vertically opposite. We need another term to describe the relationship between A and E. So what I notice is that A is in the top left corner of this intersection and E is in the top left corner of this intersection. So they correspond, their positions correspond to one another, top left and top left. So I'm going to call them corresponding angles. Okay? And A is also the same as G. These are not vertically opposite, they're not corresponding. We got to come up with another term for this. So A is on the left of the transversal, G is on the right. They alternate sides of the line. They're on the outside part of the parallel lines. We've got an interior region here inside the parallel lines, and we've got exterior regions outside the parallel lines. Well, these I'm going to call alternate exterior angles because they're on the opposite side of the transversal and they're outside, exterior to the parallel lines. So you're going to hear these words quite a bit as you go through math down the road. Okay, so let's just do another example together. If I look at angle F, all right, well, it is the same as angle H. Why? They're vertically opposite. They're across from each other. Okay, F and B are also the same. F is in the top right side of its intersection. B is also the top right side. That's corresponding positions. So you were going to say that angle F and angle B are corresponding angles. All right. And finally, F and D are also the same, but here they're alternating sides. F is on the right, D is on the left. They're both on the interior side of the parallel lines, so we are going to call these alternate interior angles. All right, so you've got a few terms here that you're going to see quite a lot of, but the more you practice, the more you'll get comfortable with them. So speaking of practice, let's do some. All right, pause this and see if you can fill in all of these blanks. These short little lines here are going to be a specific angle. These longer ones are going to be the terms that I've just gone over. So if you pause, or if you've tried this, let's see. Angle D over here is vertically opposite, meaning it's across from, well, it's got to be this one. Where's my mouse? There it is. Angle B. Okay, let's look at angle E. Angle E's alternate interior, so that means on the other side and inside the parallel lines, it's got to be angle C. All right, what about angle G? Corresponding means same position. So G is on the bottom right. The bottom right of this intersection is C. All right, now let's look at H and B. H is outside, or H is on the left, B is on the right, so they're alternate. Are they interior or exterior? Well, they're outside the parallel lines, so angle H and B, the relationship between them, we're going to say that they are alternate exterior angles. All right, B and D, well, B is across from D. It's actually the same one as up here, vertically opposite. All right, F and B, let's look at F. F is in the top right of its intersection. B is in the top right of its intersection. They correspond positions, so they are corresponding angles. Then finally, I've got one here that's a little bit of a different scenario. It says angle F and G. Be careful, they're not the same, okay? If I look here, 2 notches, 1 notch, they're not the same angle. But what do you notice when they total each other? They form a straight line. If you remember, the word for that I've shown you in this video is they are supplementary. Okay? So with that, that's all the terminology you need to know about these angles. If you want, by the time you see this video, you will have a Math Help Services assignment available to you on Math Help Services. You need to email me if you cannot find your way in. If you don't remember your login, email me and I will let you in. Just remember that this does not count for marks. I'm not going to put a due date on it. You can do it whenever you want, and you don't have to do it. But I think it's a good idea to practice it if you have the time, if you're willing to. just to try this out a little bit. Remember that you can go around Math Help Services and look at future topics that we would do. You can look back on older things. You can watch video lessons. You have access to all kinds of practice problems. You don't have to wait for me to give you homework through it. Okay? So feel free to explore. And that's it. Oh, and one of the other things I'm going to do with all these videos is I'm going to make sure to put in at least one bad joke. So here's today's bad joke about angles. I'm not going to explain it. If you have been paying attention, you know what those are. By the way, when you compliment somebody, it means you're saying something nice. So isn't that funny? They're all saying nice things about each other and they're complementary angles. It's funny, right? I don't know if this works, but I'm trying to play cricket sounds off my phone right now. Hopefully you heard that. All right, so thank you for watching again. If you haven't done so already, please like and subscribe. And remember, stay safe, take care of yourselves, and wash your hands. All right, take care, everybody.